Next talk is Anne from Microscaling, and she's going to talk about resource efficiency and self-healing systems, if I understood correctly.
Absolutely.
So, yeah, all yours.
Well, thank you very much for the introduction. My name is Anne, and I am the CTO of Microscaling Systems, and we're involved in intelligent infrastructure. And what I want to talk to you about today is a tale of impending doom, ops doom, as always. How I think we got here, which is quite a long view tale, and what I think is we're likely to do about it, what I think is likely to be coming. To help us with that. And the problem is about a performance indicator, resource efficiency, which I would quite like it to be a key performance indicator, never really quite gets there. But I think that what I want you to take away from this evening is an idea that maybe it would be a good thing if it were. It's not at the moment, but maybe it would be a good thing if it were. So the story of resource efficiency is a story of battling against adversity, doing very well, then totally failing, and then doing very well again. And what do I mean by resource efficiency? I mean the efficiency with which our applications use the underlying hardware that they're running on, the underlying physical devices, so CPU, memory, bandwidth, and also underlyingly the energy that they use. Because I've been in software, in technology for over 20 years. In almost every respect across that time, things have become immeasurably better. But resource efficiency, the efficiency with which we use our resources, it's not quite such a positive story of general upward movement. And so, as an example, currently the average efficiency of resource use globally across data centers is about 10 to 15%, which seems a bit bad. Everything seems poor. I mean, it might be that that's impossible to get higher than that. Maybe 10 to 15% is the most that we can ever achieve, but that's not the case because there are companies worldwide who are doing considerably better than that. Netflix are achieving about 50% efficiency, Google 65, 70% efficiency. So it is doable, we can do better. But why would we want to? I mean, if things are working as they are, why should we care? Why would we want to do better? In preparing for this talk, I did a little bit of looking into statistics. So data center energy use as a proportion of the world's energy use. Don't know if you know it, it was reported in The Economist last month, I think, which is or was a sister publication to the FT. At 2% of world energy use goes into data centers. So I thought, well, what does that compare to? Is that a lot? Is it not? I don't know. What other industries does that compare to? So I did a bit of digging around. Think about the aviation industry, an industry that people think of as being a terribly high consumer of energy. It's similar. It's about 2%, 2.5% of world's energy use. But people actually campaign against new runways. They really care. They consider the aviation industry to be a poor use of energy. No one campaigns against new data centers being opened. But actually, is that fair that we don't suffer that whilst the aviation industry does? Because actually, the aviation industry is a terribly efficient industry. They really don't want to be using any fuel that they don't have to use. It's a key part of what makes them competitive, cutting their energy use, cutting their fuel costs. And they're in fact really quite an efficient industry. But they are campaigned against for using too much energy. But nobody chooses to use WhatsApp rather than Snapchat because WhatsApp is more efficient in its use of energy. I have no idea. I literally have no idea whether WhatsApp is more efficient than Snapchat. And if I don't know, I assume nobody here knows, then the worldwide certainly don't know, and they certainly don't make that choice. And from the ops perspective, I'm extremely happy that people don't make that choice, and it's not a pressure that's on me at the moment to be more efficient in my data center use. It's a huge relief that people aren't campaigning outside my house because my apps are too bloated. But from a human perspective, I can't help but feel that maybe it's not such a good thing that nobody's putting any pressure on us over that. And let's face it, we're only getting away with it because nobody has the faintest idea what goes on in a data center, which is, there we go.
That's really interesting subject matter because I'm quite eco and I've kind of seen on Facebook that lots of people are actually starting to talk about this now. You know, using social media, how much data that's using, how much it's using, blah, blah, blah. So, I mean, it is slowly kind of coming to the surface.
Well, I think it is. I mean, I did read about it in The Economist last month, which means that it is getting into the mainstream press. People are starting to become a bit more aware of it. So it might be, it's never been a pressure on us, it's never come up, but I think it's possible that it might be. There was some protests against a new data centre being opened in France earlier this year as well. So yes, I mean, it's something that I think it's useful for us to be aware of. Because it's not easy to fix, which is what I'll be talking about. And I think we've got new threats coming. I mean, if we were just continuing as we are, that would be one thing. It would be bad because we're only on 10 to 15% efficiency, but I think things are going to get a little bit worse. So Internet of Things, and by that I don't mean clever fridges, I mean more smartphones and more tablets. I think I've seen estimates anywhere between 50% and 500% likely increase in data center requirements by 2020 to cope with additional smartphones and tablets. So if we, and I've also seen an estimate there's about 100 million servers already in existence in data centers. So we're talking about going from 100 million, we're talking about hundreds of millions of new servers if we keep going in the way that we are. And microservices, I actually think they're a bit of a threat. Love them, love the concept, but they have the potential to be even worse for server utilization. But we'll get to that later. So let's go back. We're talking about now, but how did we get here? What's happened in the past? Because I think the way that we've responded to things in the past often tells us how we might respond to them in the future and what we're likely to do about it. So story so far. First comeback for resource utilization was absolutely Moore's Law. I mean, 20 years ago, when you turned on your PC, it was like turning on a Hoover. It just made, it was just hugely energy inefficient. It was just sucking up energy to do almost nothing. And things have got a lot better than that. If we'd just kept exactly the applications that we have had then, and we were running on them on the servers now, they would be on, you know, literally a thousandth of the servers that are required. But of course that hasn't happened because as we got more CPUs, we got more, everything became cheaper, we used more of it because that is the nature of things. So we used more of it to have more applications, and thank goodness for that because that's what keeps us all in jobs. Massively improves our lives. But we also used it there we go, as our first opponent was developer productivity. So quite a lot of that additional capacity that was delivered to us by Moore's Law, we used to make our lives easier as developers. So back 20 years ago when I was a developer, it was really slow to write code. You know, you were often writing in non-human readable protocols that you were assembling, which were very easy to for computers to parse, but very difficult for humans to parse, and they were quite compressed, so they were cheap to send over the wire, but again, they were difficult for humans to parse. So, and moving away from low-level languages like C, which are extremely tunable, to higher-level languages like Ruby or Python. Again, they're less tunable, but they're a lot easier to write. So we moved from a world where everything was incredibly slow to write, slow to debug, slow to fix, to a world in which it's a heck of a lot quicker to produce new applications, to get things out there. We optimized for speed of deployment, and we optimized for developer productivity. And we used an awful lot of Moore's Law's gains in order to do that. So does that mean I think that productivity is a baddie in this story? No, I don't, because we wouldn't have all the stuff that we have today if we'd been producing it at the incredibly slow rate that we did 20 years ago. But I think it is something that's worth considering because we do optimize for getting applications written very quickly. But a successful application spends a heck of a lot longer alive in the field than it did being built in the lab, especially if there are multiple copies of it. If there might be millions of copies of it out there that might live for years, that is a lot more time spent executing than was spent writing it. Do I think that we should all be tearing our hair out over that and agonizing? Because we're under a lot of pressure to actually get apps out there, not to make them energy efficient. But I'm not saying we should castigate ourselves over this, but it's something to potentially occasionally think about. So what was the second comeback for resource utilization? Well, once you've got hardware optimized, so Moore's law is coping with that. All those solid state physicists are doing an absolutely amazing job of delivering us more hardware capacity for the same amount of money. Then your next option is to start looking at how you are using your servers to be more efficient. And as we know, a very inefficient way of using servers is to have a small application sitting on a server. Maybe that small application is only using 2% of the CPU. The rest of the server is on, so there it's taking up space, it's taking up electricity, but it's not doing anything useful for you. So originally back in the 60s, but more recently than that, about a decade ago, people started to say, well, could we divide these servers up into smaller virtual servers? So rather than, obviously if you've got a tiny little application, one option is to just stick it on a tiny little server, but there are so many logistical problems with that isn't really a solution. But if you can effectively create tiny little servers, virtual servers on all your physical machines, then you can potentially achieve really, really good utilization. And that was a lot of the reasoning behind the use of virtual machines originally 10, 15 years ago. And there was a strong reason for doing it, because if you're running a physical data center, certainly this was the case for me 15 years ago, running a physical data center, putting in additional machines is a gigantic pain in the neck. If you've, especially if it's not your data center, if it's a shared data center, just getting a new physical machine in there is really difficult. Getting it, the electricity for it, everything associated with that is a pain. So you're highly motivated as an operational person to find a way of getting better use out of the servers that you already got there. And that might be just by buying new ones, which are twice as good for the same space. But it's also about using them more effectively. And VMs were a very, very good way of using those servers more effectively and getting excellent server density. So everything looked absolutely. So at this point, it's amazing. Great. We're solved. With all the problems are solved. It's absolutely fantastic. Or were they? I don't know. Perhaps they weren't. No, they weren't, because the cloud came along. And the cloud was absolutely amazing, because why we liked it as operational folk, and as developers, it turns out, is because it completely takes the pain away for creating new machines. Suddenly, all of that motivation that you had to use your servers more efficiently is gone. Because somebody else is putting the servers in for you. You don't have to worry about where they are. You don't have to lug them. You don't have to order them. You don't have to find space for them. That is all done for you in the cloud. The magic cloud will do all that for you. Which has its positives and its negatives. The other thing about the cloud is that you can only choose from quite a small range of VM sizes. So, you can have a small VM, or you can have a medium-sized VM, or you can have a large VM, or a hugely large VM. Maybe you've got a fair range, but it's not massively granular. So at every point when you're working out which VM you're going to put your application in, you've got a choice. Am I going to have a VM that's too small and it's going to fall over, or am I going to have a VM that's too big? But it might still fall over because we're all terrible at working out predicting demand in advance. So even if it's too big, it might still be a problem. So I could just make it hugely big and vastly over provision. And then the only problem for me would be cost. And actually, what I don't know if you find, generally when I'm going out and talking to people, cost is not really the pain point that most people are experiencing. They're much more interested in productivity of their folk, who are really hard to get at, than they are in hosting costs. So it's not a really effective way of causing people to be more efficient just because the hosting costs are higher. So again, there's really nothing there that's stopping us from over-provisioning, and there's a lot that's pushing us to over-provision, because we can't react in real time to change what size VM we've chosen either. You just have to run it and hope that and keep watching things, and maybe occasionally you'll size down if you're going through a cost-cutting exercise, but generally speaking, you're going to just be over-provisioned most of the time by a lot. So DevOps, surely DevOps will save us. Surely DevOps is the solution to all of these things. And DevOps is fine, and I think it's great, and it's part of any solution. And fundamentally, without DevOps, we wouldn't be able to manage the enormous over-provisioning that we have. We wouldn't be able to manage the thousands and thousands of servers that we're over-provisioning to the tune of if we didn't have DevOps to help us. But it helps us, but it doesn't really drive us to be more efficient in our use of resources. So then we come to microservices, and I'm going to say something a little bit controversial here, because I love microservices. I love the concept of microservices. I love the architectural idea of the separation. There's such power in the idea of microservices. But it could be extremely poor for server density, for resource utilization, because the reason why we like microservices is because they're not monoliths. Because monoliths are really hard, they do complicated things, and they're very hard to support, and they're slow, and you can't move them around. And there's loads of nasty things about monoliths. But one of the nasty things about monoliths is that they're hard to support because they're really quite clever. They have things like internal queues and internal scheduling, where they start and stop threads, and they look at what's going on the machine, and they respond to what's going on around them, which is actually quite good for your resource utilization. A lot of the intelligence that goes on in monoliths is actually about resource management, and that is, as you split things off and you start to pull things apart and put them into microservices, quite often one of the first things you'll do is get rid of your internal queues and start to use the amazing external queues that we now have, like Rabbit or Kafka, which are fantastic. But they're no longer on the same machine as your application anymore. They're now separated, and maybe they might be separated by quite a long way. So now, instead of having very simple I/O operations, you've got network traffic between your queues and your services. So innately, that is a more inefficient use of resources, and it's more complicated, and it's more difficult to manage, and it's more likely to result in pager alerts than just having a queue that was internal to the application to start with. Also, an awful lot of the complexity of monoliths was in kind of that clever internal scheduling and thinking about your local resources and all that kind of stuff. As you move things out into microservices, you want things that are simpler. That tends to disappear. And if you lose it entirely, then you're just going to have you're just going to have poorer utilization across your whole system. So there are great things about microservices, but there are also some risks in microservices that it's worth us being aware of. So I'm saying now, is this just disastrous? Are we doomed because we're definitely going to do microservices, or we're all doomed? Is everything going to go horribly wrong? Well, if only there was some technology that addressed some of these issues that VMs aren't quite addressing. If only there was some kind of technology that would let us maybe box things up in a lighter weight way than VMs. But and maybe it would be faster to instantiate. Maybe it would be in the kernel rather than in user space. Maybe there would be some technology that could do that for us, and therefore yes, well, I don't know, what could it be? Oh my God, it's containers. And we talk about containers a lot as development technology because it's, at the moment, developers are championing it and it's part of continuous delivery and it really feels like a bit of development technology. But it wasn't invented as a bit of development technology. It was invented as a bit of operational technology by arguably the world's leaders in better server density, better resource utilization, like Google, who use it to do really well at packing applications onto their machines. They use, so obviously we're quite familiar with the idea that containers use namespaces to divide things up and to provide a little bit of security, and then they will actually, the C groups lets you effectively package up your application and give it bounds like a percentage. You're allowed to use this percentage of the CPU, you're allowed to use this much memory. And that way you can potentially get very fine-grained use of your physical servers. Potentially the same kind of improvements that we got from virtual machines, we can achieve again through containers. Because unlike virtual machines, you don't have all the overhead of running a whole guest operating system on top of a host operating system and all the virtualization around the outside. So there's lots and lots of potential there, which is very good. But if only there was some kind of nice interface that went round the outside of the container that everybody used, and then you could write loads of tooling that would mean that not only were you running these containers locally, you could move them easily from place to place. That would be amazing. If only that existed. My God, that exists too. So Docker has been enormously useful at effectively putting a nice little easy grip handle on your containerized applications and making it much easier to write tooling and move things around so that you're not only talking about packing things very effectively onto a box, you're also talking about packing things effectively across your whole data center, because you can say, well, actually, with the use of an orchestrator, you can know what's going on holistically in your entire data center, and you can start to say, oh, well, actually, that application would fit in better over here, and this application would fit in better over here, and I can move it around quite quickly, as long as I can move things by starting and stopping them quite fast. And there are loads of orchestrators out there. Too many, actually, I would argue, because that's quite difficult to choose between. They're still quite early as well. This is still somewhat aspirational, but it's coming. It's coming. So I think we should really be expecting and demanding more intelligent infrastructure to be coming along in the next 1 to 5 years' time, because we need it if we're going to run microservices that have lost some of their intelligence. Monoliths, they were a pain in the neck, but they were pretty intelligent about what they were running on. Microservices are less intelligent, they're more distributed, making them each part simpler, but the whole really potentially very complicated indeed. And I think that will be hard to manage efficiently without automating it. And the key to automating it will be containerizing it, I predict, and using orchestrators to get a lot more intelligence into your infrastructure. And it's the right place for it to be, because you don't really want to have to write the intelligence every time differently into each monolith, when you could be pushing that intelligence into the infrastructure. And by that I mean the orchestrators, also the infrastructure components like the message queues, that can react a little bit better, can see what's going on across the whole systems and start to optimize where your applications are running, potentially what they're doing, what modes they're running in. And with that, obviously, that is the only way as well you can get the kind of self-healing that we're really going to need in order to manage these extremely complex distributed systems that are emerging from microservices without everybody being paged like crazy all night. Right, yes. So what am I talking about? What kinds of things? So some of you may have seen this before. This is an example of a little scheduler we wrote on top of. This runs on top of all of the orchestrators, basically, on AWS or Azure or bare metal or wherever you choose to run it. And we just wrote a very, very simple scheduler and said, I want you to talk to your local orchestrator. And I'm going to have two container types, two types of applications. a high priority application, which is the dark blue one, and a low priority background application, which is the lilac one there. And I'm going to fake up some demand. And the faked demand, the simulated demand, this is random demand, is the red line there. And what we told the scheduler is to tell the orchestrator, meet the demand with your high priority containers, and then fill up the rest of the space with your low priority containers. And here you can see that's a win, although there's no demand there. That's a win, that's a win. That's not a win because it hasn't got enough, but that's a win at the moment. There we go. How long? Yep, that's a win. So this is a very, very simplistic example of the kind of thing that a clever scheduler could do. Oh, not even a clever scheduler. This is a really dumb scheduler. If you start to combine containers and services and orchestration with a little bit, maybe tying it into your metrics. There we go. All right. Sorry, I'm going to put my specs back on. Good. Right. So I will not lie to you. None of this is trivial. This is fiddly to do. This is not something that anybody is going to learn how to do by reading one article on Stack Overflow. This is akin to the level of effort that we had to go to learn how to use VMs and VM orchestration. This is the same kind of level of investment again in time. But imagine if we hadn't done that now with VMs. Imagine what a world it would be if we hadn't made that investment in time. So I think it is absolutely required. And will that give us a win? Will that be will we be, if we actually get to that point and maybe we achieve Netflix's resource utilization numbers 50%, will we be happy? Well, probably for a small amount of time before we find something else to do with with all the resources that we've just freed up. But as we heard earlier, I think this might well be required. I don't think we're going to be able to easily build 4 times as many data centers by 2020. And at some point, people are going to find out that we are so energy inefficient and possibly wanted to do something about it. So that's me. Any questions?
Wait.
Oh.
Hi. How much do you think this is up to individual companies to solve, and how much should cloud providers just be doing this all for us? And Amazon have things like Lambda and stuff now that's sort of going that direction.
I think they will. I mean, some of the cloud providers, I think, I'd be amazed if, I haven't seen the numbers from Google, but given that they are kind of the world leaders in this kind of resource efficiency, I would expect they would be pretty good. AWS do what we demand of them. So they will have energy efficiency if we demand it. But also it's in their best interest because for them, energy costs are a big problem, and they do feel the pain putting in the new data centers. So for them, there is more motivation than for us. So to a certain extent, we might just be saved by moving absolutely everything into the cloud. Yes, that will be a very locked-in world. And right now, it's certainly in AWS's best interests for us to over-provision. So yeah, you'll be completely in the hands of Amazon, who are not well known as philanthropists. So we might need to provide some demand ourselves there. But that might be all we need to provide, demand.
You said that you didn't think cost was something that was really driving people very much, but I wonder if there are other things that might drive people. And I was thinking about performance. So my guess is that if we've not got caching right, or if a web page is slow, then it means the server's doing lots, which must in turn be using energy. So if we get performance better, and are mindful of cost, then hopefully those two things together start giving us improvements. Does that seem to make sense?
It does. I would really hope that that was the case. But we have pretty terrible resource utilization at the moment, which suggests to me that kind of logical argument, which I would also have thought would make perfect sense, is not really doing enough. People are having to put in it's quite fiddly to do this. And I think it's only people who are really feeling the pain, like Google or Netflix, who are really going to the work required. Oh.
Which side is it? So you talked about energy efficiency and focused on how we best use our hardware by piling more containers or software. What about efficiency of software design itself? Because we see a lot of examples that bad code just does things that it doesn't need to do for 5-6 hours.
Oh, absolutely, yes. This is not only an ops problem, this is also a dev problem, but this is an ops meetup. I can go and harangue developers somewhere else. But you're right. We could do more. We could do better there as well.
Is this really an ops meetup? Because I'm in the wrong place.
Great. Thank you very much, everybody.